Okay, everybody, I wanted to talk a little bit about significant figures here and give you a few examples. I'm going to do this in two videos. The first one is going to be just what are sig figs, which numbers are significant at measurements, which are not. And then the second one is going to be calculations in significant figures. So first off, significant figures, these are all the numbers read off a measurement device and the estimated digit. So if I was to come over here and if I was to measure an object that lands right here, this is a centimeter ruler, by the way. So 0, 1, 2, 3, those are centimeters. In between are millimeters. So if my object fell right here, right on this, right here, another terrible color. Here we go. If my tool, whatever I'm measuring, fell right here, I would read exactly in the measuring tool. So I know it's 5 centimeters, 5.1, 2, 3, 4, 5. So my measurement would be 5.50. We always estimate the very last digit. So if whatever you're measuring falls directly on a tick mark, okay, that's your last digit that's read off the measuring tool, and we always estimate the last digit. So this measurement would have three significant figures. Sometimes they call them sig figs or significant digits. I usually call them sig figs. So this measurement would have three sig figs. If something was to fall right here, then I would read it as 1.1, 1.2, 1.3, 1.3, and I estimate my last digit as 0. And then again, centimeters, and I would have three sig figs. If something fell right in between, so let me make this a lot bigger. So let's say whatever I'm measuring fell right in between these two tick marks right here. Then I would read my measuring tool as 8, 8.1, 8.2, and I think it's right in between the 0.2 and the 0.3. So then I would read it as 8.25. So the 5 is my estimated digit because I'm estimating where it's landing between the two tick marks. So again, I would have three sig figs. Same thing here. As I'm looking at my measuring tools, the first thing I have to do is I have to figure out what increments are each of my graduated cylinders increasing by. So here I got a 2 and a 3 here. So they're going to increase by 2.1, 2.2, 2.3, 2.4, 2.5. So if I was to read this 2.1, 2.2, 2.3, and my estimated digit is 0, and that's my measurement. So since I've read the 2 and the 3 off the measuring tool and estimated my last digit, I have three sig figs. So if you are measuring something directly off a measuring tool, all the numbers that you report plus that estimated digit are significant. However, if we are doing calculations with measurements, we need to know what numbers are significant or what are important to our measurement and which ones are not. So we have significant figure rules and we have rounding rules in science. So that way, if I was to give a whole sheet of paper of measurements, calculations with measurements to one scientist and a different scientist, they are both going to come up with the exact same answers because they know which numbers are significant in a measurement and they know the rounding rules. So I'm going to start with what numbers are significant in a measurement. And then I'm going to talk about what is not significant. So all non-zero digits are significant. So if I had a measurement that's 12.5 centimeters, okay, 12.5 centimeters, I have three sig figs. If I had a measurement that was 13 grams, both of these are non-zero digits, so I have two sig figs. That one's easy. Any zeros that are held captive between non-zero digits. So if I have a number like 1204.5, this zero is significant because he's captured between two non-zero digits. So if I was to say how many sig figs are in this measurement, you would tell me 1, 2, 3, 4, 5. 5 sig figs. Trailing zeros. So these are zeros that are to the right of a decimal point, and I'm going to say, and the right of a non-zero digit. So for instance, if I have 25.0, that 0 is to the right of a decimal and the right of a non-zero digit. So we'll make that a centimeters. So I have 3 sig figs. If I have a measurement that looks like 120.00, both of these are going to be significant, and this guy is significant as well. Okay, so this guy is significant because he's to the right of a non-zero digit, and he is trapped between the decimal. These guys are to the right of the decimal and to the right of a non-zero digit, so those guys are significant as well. The numbers in the M or coefficient position in a number are always significant. So if I have 4.96000 times 10 to the fourth, okay, every single one of these numbers are significant. If I have 2 times 10 to the negative 12th, I have 1 sig fig. Exact numbers or counted numbers. So I know for sure 1 meter is equal to 100 centimeters. Every single one of these numbers are significant. So I'd have 3 sig figs here because it's an exact number. Or if I was to make you guys count everything I have in this beaker, it's a counted number, which would be considered an exact number. So if I had 20 items, both of those are going to be significant because it's an exact number or a counted number. Okay, so what's not significant? Zeros trailing with no decimal point. So if I have 32,000 millimeters, those 3 are not significant. That is not a decimal, that is a comma. So it's 32,000. These are not significant because I can very easily move my implied decimal point and put this in scientific notation, and I have the exact same number. So these guys are just considered placeholders. So if I have 1, 0, 1, 1, 2, 3, 4, 5, 6, this guy's significant because he's captured between 2 non-zero digits, and all of those are not significant because they are not to the right of a decimal point. So this value, 101 million, would only have 3 sig figs. Leading zeros are not significant. So if I have a number like 0.496 milliliters, this is leading into a decimal. Okay, so he's not significant. So this would have 3 sig figs. Or I could have a number like 0.00039285 milliliters. All of these zeros, they're leading into a non-zero digit. A lot of times they'll say the zeros that are to the right of a decimal and to the left of a non-zero digit. I just like to look at them and they're all leading into a non-zero digit. Same reason as up here, I can put this into scientific notation and the value of the number doesn't change. So I can go 1, 2, 3, 4, 5, 3.9285 times 10 to the negative fifth. So I would really have 1, 2, 3, 4, only 5 numbers that are significant. Okay, so let's take a look here. So in this number, we've got 4 sig figs. That guy's significant because he's captured between 2 non-zero digits. He's significant because he's to the right of the decimal and the right of the non-zero digit. We have 4 sig figs here. All first 3 numbers are non-zero digits, so they're significant. That guy is significant because he's to the right of a decimal and the right of a non-zero digit. This value only has 5 sig figs. This guy is not significant because there's no decimal. These two are significant because they're captured between the 1 and the 8. So I have 5 sig figs. Scientific notation, all numbers in this spot are significant, so I've got 3 sig figs. This guy is leading, not significant. These two are leading, they're not significant, so I have 2 sig figs. Our number right here, 3,200,000. Okay, I have 2 sig figs. These are not significant because we've got no decimal. Okay. I think I'm going to stop there and do another video about rounding and then another video about calculations. Okay, I'll see you soon.